Welcome to Podcast Summit Asia. Yesterday, Enrico and Matteo shared the new features and updates in BookKeeper Virtual Manager. It's really a cool tool. And today, Enrico will the new feature in Apache BookKeeper that allows Bookie to have dynamic network addresses and also multiple endpoints. As we all know that Enrico is very active in open source project. He is a PMC member of both Apache BookKeeper and BookKeeper committer in Apache Maven. So you no wonder that someone from our audience has said that, wow, I see this is I'm familiar with the face and with the name, that. So we feel that you are passionate about open source project, and from your talk, we are sure that our audience will benefit a lot. Now let's welcome Enrico to give your talk.
Thank you. Welcome everyone. I'm Enrico, as Jennifer introduced me. Today we are going to talk about BookKeeper and the latest features in the latest release, especially about BookKeeper Proposal 41, Bookie Network Address Change Tracking. Okay. Here we are. We will start talking about BookKeeper core concepts. So we will have a little deep dive into how BookKeeper works. We will see new recent new features, the Bookie address endpoint info, BP-38, and the new Bookie ID, it's BP-41. In the end, we will see a use case for this new feature with RDB, that's a SQL database built upon Apache BookKeeper. Enrico has first told I'm an open source enthusiast. I'm a software engineer at emailsuccess.com and magnews.com. I'm member of BookKeeper and ZooKeeper PMCs, and actually I'm the PMC chair of Apache Curator. I'm the author of RDB and Blazing Cache. So let's start with Apache BookKeeper. BookKeeper was born inside Yahoo Research some time ago. Initially, it was it started as replicated write-ahead log for HDFS. So basically, Apache BookKeeper is a write-ahead log. But during the last years, many companies adopted it for storage in general. It was donated to the Apache Software Foundation as a ZooKeeper sub-project, but it graduated as top-level project in 2015. Now it is the storage layer for Apache Pulsar, or for instance, it's the write-ahead log for RDB. Let's see the core concepts in BookKeeper. If you are using Pulsar, probably you are already familiar with this concept, because basically Pulsar is a layer on top of Apache BookKeeper that provide the PubSub and all of the other greater feature of Pulsar. But internally, it's an abstraction over Apache BookKeeper. We have the Bookie, the ledger, the metadata service. We will see how replication works, the fencing feature, and the LAC, the last add confirmed protocol. The Bookie is the server in Apache BookKeeper. Each Bookie is totally independent from the other servers. This way you can really scale out easily, because you just have to add Bookies. The Bookie does not implement much logic in Apache BookKeeper. It's mostly a container of data, because all of the logic is in the client, and we will see this later. Basically, in the Bookie, you have two main components. The journal that serves the writes. So when you write to Pulsar and Pulsar writes to the Bookie writes in this local file, this journal. And the read path is served by the mem table that basically cache, and the entry log ledger storage, that's the persistence of the persistence layer of this cache. And reads and writes follow totally independent data flows. So this is total I/O isolation. But the Bookie is identified by its network address, and especially the network address of the main binary protocol endpoint, the RPC endpoint. So you will see Bookie IDs in the form of host name, DNS name, colon, port, usually 3181. The ledger, on the other part, is the main and only data structure. It's an append-only sequence of bytes. So you write the entries. The entry is the unit of data. When you write and you read, you can only write full, the whole entry. When you cannot read in the middle of one entry, and usually these entries are little. In Pulsar, an entry is a message or a batch of messages. A ledger is totally immutable once closed. And you cannot delete the single entries, only the whole ledger. Also in Pulsar, when you have the rollover of the ledgers, you see that portions of the topic are deleted as a whole, because in BookKeeper you cannot delete single entries. There is only one writer per ledger, and you can have multiple readers. And the readers can read even if the ledger has not been closed. Usually, in the typical usage of BookKeeper, you have one writer that writes, and you have many readers that are tailing the ledger. That is, they are reading the latest written entries. We have the metadata service. A metadata service contains the system-wide configuration, so something that every entity in the system must agree on, like the layout of other metadata, the ledger metadata, we will see that later, and it provides service discovery and also distributed logs for the auditor. It is implemented with Apache BookKeeper, but is totally pluggable. And in the Apache repository, we also have a ATCD implementation. Clients and bookies connect directly to the metadata service. This is important because in the BookKeeper cluster, both the clients and the servers must connect directly to the metadata service. In the current version of BookKeeper, this is the architecture. Let's see how replication works. When you deal with the Apache BookKeeper, you always have three numbers, three knobs. The ensemble size, that's the number of bookie to write a ledger. The write quorum size, it's the number of copies for each entry. And the acc quorum size, it's the number of confirmations to wait for. So the writer sends a copy to each bookie and those values. You can see this other word in BookKeeper, ensemble change. That's simply you choose another bookie, because when you're writing, a bookie fails, and then automatically and totally in transparent way, the system chooses another bookie if it is available, and the writer can continue writing seamlessly. Let's see how an application that writes to the BookKeeper works. In this case, the application for Pulsar is the Pulsar broker. It's the managed ledger. So the application creates a ledger and issues a call to the BookKeeper client. The BookKeeper client is written in Java, and currently it is only in Java. Basically because the BookKeeper client, as we are going to see, implements most of the logic of BookKeeper. So if you want to implement a BookKeeper client in C++, you have to copy and paste all of the Java code. There's no way to share code. There are works in order to improve this, but it's not a topic of this talk. So the Java client issues operation, the write operation to the metadata service. This is only one metadata service operation. You can assume that a metadata service operation is slow, or it is really slower than a write to BookKeeper. Basically, because for the metadata service, if you are using BookKeeper, but it's a detail, you have to wait for a quorum of nodes to acknowledge the write, and this is usually slower than the other path. So the point is that we have only one metadata operation. Then the client sends the entry to the configured number of bookies. In this example, we are using 433. So we are writing our ledger to 4 bookies. We are keeping 3 copies for each entry, and we are going to wait for 3 confirmations. The bookie confirms that the entry has been durably written to the journal, and by default it waits for the fsync. So you can you are sure, you are guaranteed that the entry is persisted locally and fsynced to the disk. We are using 433. Then the bookies send their acknowledge, and the client is waiting for the confirmations for the X. When the configured quorum size is reached, then the BookKeeper client acknowledges back to the Pulsar broker the write. Then we are going to write the second entry. We are using 433. So we are using the striping feature of BookKeeper, and we are spreading the entries over 4 bookies, but each entry is written only 3 times. So the second entry goes to Bookie 2, Bookie 3, and Bookie 4. And this is very good because you can, in parallel, write to many bookies, and you can be really fast. Then we are waiting for the confirmation of the write, and acknowledge back to the application, and then the application closes the ledger. In this case, Pulsar broker closes the ledger, and this is the only second metadata operation that seals the contents of the ledger. The ledger is immutable. No one ever can write to it anymore. Let's see what is fencing. Fencing is, I think, it is the most interesting and cool feature of BookKeeper when I started using it. You have only one writer per ledger. This is straightforward because you can only create once the writer for the ledger, and when you use the write handle, you cannot recover it anymore. But in a system like Pulsar or any other replicated system, when you have a write log, and usually you have some entity that is allowed to change the status of the system. In this case, in the case of Pulsar, you have the Pulsar broker, the client, the Pulsar client connects to the Pulsar broker and writes a message to the topic, and then the Pulsar broker that is the owner of the topic is allowed to write to the ledger for the topic. But in case of network issues like partitions or simply slow systems, Pulsar automatically chooses another broker to be the owner of the first broker. And then the clients start connecting to the new broker. But if the old broker is still alive, it could try to add new entries to the ledger. And you will have two brokers that write to the same system, to the same topic. And with fencing feature, the second broker, when it is elected as owner of the topic, it fences out the first one. So the old broker, when it tries to write a new entry to the ledger, it receives a special error code that means you've been fenced out. So stop thinking that you are the leader, the owner of the topic. And this, the operation that the new owner issues is the recovery read. This way we can guarantee a consistent view on the contents of the ledger and also of the overall system. And fencing is only at BK level. And fencing works only on one ledger, but you are going to concatenate more ledgers because you can only write to the ledger once. And when, for instance, you will start your broker, you have to start a new ledger. But the fencing works only on one single ledger. And so you have to concatenate more ledgers. This is the managed ledger feature of Apache Pulsar. And we're using Zookeeper compare and set feature to concatenate ledgers safely, because it can happen that two Pulsar brokers start to think that they are the owner of the topic. So only one can succeed in being the new leader. The last add confirmed protocol, it's the LIC and Bookkeeper code. It's the last entry acknowledged to the writer. This is somehow tricky to understand sometimes, but it guarantees that the reader cannot go beyond the writer. Let's say that we have a counter. There's one entity, one agent that has a counter, and the value of the counter is 2. And then you are writing to your log, the write log, that the new value for the counter is 3. And you have another entity that is reading from the log and is replicating the state of the counter locally. So you have 2 and 2, and the writer writes the new value is 3, and the reader reads the new value is 3 and applies the same value to the local copy of the data. But the reader can only update its local version of the data only one after the writer, because it cannot happen that the reader is beyond, he is ahead, because the reader could answer to their client, to its own clients, the wrong value. Because if the writer crashes, actually the value of the variable is not 3, it's still 2. So Bookkeeper when provides this feature that when the writer writes, it also tells to the Bookie what is the current tail of the ledger, the current safe point to read. And this way, the readers are not allowed to try to read beyond that safe point. The book itself, it's dummy. it doesn't know about the LAC. So it's a contract between the reader, the writer, and the reader. And this is everything implemented in the Java client. Recently, we have enabled Impulsor in the next 2.7 version, the explicit LAC. It's another way to transmit the LAC value from the writer to the reader without actually writing entries. Ledger metadata. On the metadata service on BookKeeper, we are writing for each ledger the state. Open, someone is writing. In recovery, someone is performing a recovery read, and closed or sealed value. The LAC value, custom metadata. These are interesting and very useful information about the ledger, because you can see in the ledger metadata and in the BookKeeper cluster why you have those ledgers, and use tools like BKVM to see visually the meaning of your data. And the data location. So where is the data for each segment? Because when the reader wants to read the data, it has to find the data. And so it looks up the metadata on BookKeeper, and it reads the position, the network location of the data. And now we are storing the network addresses of the bookies. That's the Bookie ID. Limits of the current design. The previous version of BookKeeper. The bookie cannot use a dynamic network address, because if you change the address, the bookie won't booked. There's a mechanism that protects bookie to not change network address. The readers won't find the data at all, because in the metadata, it is written that the data is on bookie1.google.com. And if you move the bookie to another network, or you change the DNS name, it is not possible to retrieve the data anymore. Also, clients only know about the network address of the main RPC endpoint of the bookie. The bookie also exposes an HTTP API of if you're running the stream service server, stream storage server. There's nothing to know that the bookie is actually exposes this service. We are using another discovery service, and also we cannot add new protocols without tricks, because that is the network address of the bookie binary protocol with protobuf. For instance, when you are using TLS with BookKeeper, it starts the communication in plain text, and you upgrade to TLS with the start TLS. But if the bookie would advertise the presence of the pure TLS protocol, the client could start directly in pure TLS. And also, ledger metadata are tied to the network. You cannot move the bookies. In BookKeeper 4.11, we implemented BP-38, and we enhanced the discovery system. Now the bookie advertises on BookKeeper their capabilities, security, authentication, and the endpoints, the bookie RPC, HTTP server, so we can support new protocols in the future. Pure TLS, or new authentication schemes, or also in BKVM, we are going to use the HTTP server information to discover automatically the HTTP API of the bookies. And it is totally compatible with previous version. That is, if you don't add new protocols, if you don't move the bookies to another location, the BookKeeper 4.11 client works with bookies very old Bookies. And with Bookkeeper Proposal 41, we introduced the Bookie ID. Basically, it is to use a generic, any string you want as an ID for the Bookie. So it can be a unique identifier. It can be any kind of ID for the Bookie, and we are abstracting from the network location of the Bookie. We are abstracting from the Bookie RPC endpoint. So now you can move the data to a new network or simply change DNS names, or in theory, but there's no implementation, you can backup your metadata and move your data and your metadata to another network. And metadata do not rely on network addresses. They're totally independent concept. The client can choose which protocol to interact with the Bookie. Currently, we are only supporting the binary protocol and with protobuf and StartTLS. But in the future, I know that there are contributions that are coming with other protocols, and this is really a new era for Bookkeeper. I want to make a real example of how to leverage these new features with RDB. RDB is a distributed SQL database. It is using Bookkeeper as write log, but also it can use Bookkeeper as storage for data. But usually you are using only Bookkeeper as write log. Each server has an ID. It's an opaque string. Usually it is a random string. And it supports dynamic addresses. Because basically when the server starts, it announces to the discovery service that is implemented with Apache BookKeeper that the current network address of the node is the current address. And so clients can follow network address changes for the RDB nodes. And with RDB, you can run the Bookie inside the same JVM of the database or inside the same machine, because usually RDB users are pretty small clusters of 1 up to 3 machines or 5. And you run the database and the Bookie and the metadata service on all of the machines. But with the previous limits in Bookkeeper, you cannot move the nodes in another network. You could not change the network addresses so easily. With Bookkeeper 41, we can support dynamic addresses, even for the Bookie. How it works in the case of RDB, this new feature has been released last month with the latest version of RDB. You can check it out on the GitHub. It's an open source project, Apache 2 licensed. The ID depends only on the data, so you can simply store it on the same device. At the first boot of the node of RDB, the server chooses an ID and store it locally together with the data. Automatically, the system is configured to tell to RDB and to the Bookie to use that ID as Bookie ID or node ID in the case of RDB. So you can restart the machine with another address. You are going to keep the data. Clients automatically detect the presence of the data at the new address. And it's simple. But there's a lot of stuff to make it work, actually. Summary. Wrapping up, in Bookkeeper, we use the network addresses for metadata, and you cannot change the network or network address or move the Bookie to another location. We could not add new protocols or feature to the Bookkeeper without making tricks like start TLS or out-of-band network service discovery. With the Book ID, BookKeeper 41, those barriers are totally dropped. Now you can use Bookies with dynamic network addresses. You can extend BookKeeper with more protocols. RDB and hopefully soon Pulsar can now totally abstract from networks. So we can tell that we have serverless storage services. I'm saying hopefully soon Pulsar because the upgrade of BookKeeper is in the upcoming Pulsar release 2.7.0, and when we have that release, we can work with Bookie ID. So now it's time for questions. And
thank you, Enrico. Actually, we have one ask, as BookKeeper is implemented in Java, how much impact does gmgc have on the latency of read and write?
Oh, as far as I know, and both the Java client and the Bookie have been there are a lot of work to make it really efficient. We are trying to use to squeeze all of the resources of both the client and the server. We are using lots of tricks with Netty on the client and the server. We are recycling objects. We are trying to use direct memory and be really as much efficient as possible. There are lots of great engineers that are working on BookKeeper and Pulsar that they are trying to make it as fast as possible. And also on the Bookie side, when Java is writing to the disk or reading to the disk, we are using JNI, so native interface, in order to leverage more capabilities of the Linux operating system. So being written in Java, it is very useful because it is portable, and it is not, in my experience, it is not a bad thing. Yes.
Okay. Another question is, will BP-38 be fully backward compatible?
Yes, it is fully backward compatible. BP-38, it's only an enhancement to the discovery system. So when the Bookie writes to the zookeeper, in the older versions, it only created an empty D node on a path. It's like Bookie with the name of the Book ID. Now with BP-38, we are writing into that D node data structure that enumerates all the endpoints. BP-41, it's the feature that uses that information, is compatible with older Bookies and clients as far as you do not use the Bookie ID feature. So you are using DNS column port as Bookie ID, and as soon as you are using only the known protocols for the old clients and old Bookies. We have lots of integration tests in the Apache repository that are running new clients with old Bookies and new Bookies with old clients. So we are sure that everything is working. In Apache BookKeeper, but in the full Pulsar stack, Zookeeper, BookKeeper, and Pulsar, we are taking very much care. We're paying much attention to being, we want to be as much as backward compatible as possible, because we cannot break things. Our users are guaranteed that if they upgrade, they know that they can. It works, and it is not breaking compatible with the past, because lots of there are lots of users of Zookeeper and BookKeeper, and now of Pulsar, and we pay really much attention. It will be a big damage to the community and to the overall ecosystem if we break things. So we are very paying much attention to it.
Okay, another question also related to BP-38. He asks, what are the benefits of BP-38 for Pulsar deployment on Kubernetes?
Okay, I still don't have production experience of it, but with this new feature, especially the Bookie ID, I expect that you can simply run the bookies. You don't have to stick the bookie to static DNS names. You can use pure dynamic addresses, because the identity of the bookie is written to the data. So you can pick the data, you can move it to another cluster totally seamlessly. In the future, I think that the Bookie may also expose on the Bookie endpoint info more information about the pod or of the Kubernetes environment, and we can leverage it for placement of data. Now the Bookie tells about it itself, and we can use that information.
Okay, that's great. So actually, Laura is in this hopping platform. So I'm not sure whether Uncle's answer fully solved your question. If not, you can also connect with Uncle. We have a few more questions from other platforms as well. The first one is, since there are some limitation of BookKeeper, do you have any plan to improve it? And you just show us that the limitation of BookKeeper, yeah.
Since there are some limitation on BookKeeper, do you have any plan to improve it?
Yeah.
Okay. I read the question. Limitation of BookKeeper. Oh, there are a lot of movements in the project. Yeah. I know that current limitation. We had that problem with network addresses, and we solved it. Now we are working on making the Bookie faster and use less disk usage. I know that some company is going to contribute a change about we are writing data to the journal and to the ledger storage, so we are duplicating the data. It's great, very big write amplification problem. But I know that there are going to be contributions in the direction of do not writing to the journal, but only to the other disk, or providing the same guarantees.
Okay, thank you.
Also, in the security, in the security of BookKeeper, we are only supporting very few authentication protocols or encryption protocols. BookKeeper is pluggable, but in the open source repository, we only have very few implementations of authentication. So I hope that someone could contribute their implementations in security.
Yes, sincerely, we encourage everyone find the bug and improve it together. Another one is question is not related to BookKeeper, but it's related to TrueKeeper. However, those are much related to it. So I also forward the question here. He asked, since Zookeeper is the bottleneck for Kafka in scalability, and Kafka decided to remove its dependency on Zookeeper in the proposals. So yeah.
Okay.
So is there a way to improve Zookeeper and help Kafka on it?
Okay.
And do you have any answer on it?
Okay. Regarding Kafka and Zookeeper, I'm not going to talk about it. No, but regarding Zookeeper, in Zookeeper project, there are lots of movement now because since during the past 2 years, from Facebook and from Twitter, they started to port back most of their changes. You know that Facebook is running the biggest clusters of Zookeeper in the world, and they started to contribute back all of their work, and also from Twitter. And Zookeeper is now more and more, I'm talking about the Zookeeper project and community is really more and more active nowadays. And probably the problem of Kafka and Zookeeper is not about Zookeeper, but it's not a problem for me. Regarding BookKeeper and Pulsar and Zookeeper, Pulsar is using BookKeeper. BookKeeper is using both Pulsar and BookKeeper. They are using Zookeeper the right way, because Zookeeper is a metadata service, and it was designed to share, to spread the configuration, to share a configuration among systems, and to support some kind of operations. Basically, you don't have to use Zookeeper to write data, or to it must not be in the hottest spots. So I think that for BookKeeper and Pulsar, using Zookeeper is a really good choice. And I hope that in the future we will be able to leverage the new features in Zookeeper that we are not using in BookKeeper and Pulsar. I'm also trying to help in BookKeeper and Pulsar community to upgrade to latest BookKeeper and Apache Zookeeper versions, because I think that most of the people know about Zookeeper, about how Zookeeper looked when it started a long time ago, because there was a book published about Zookeeper, and that's a great book. I started following Zookeeper because I read the book, but Zookeeper project really grew beyond that basic features. Now we have TTL nodes, we are containers, now we have persistent recursive watches, lots of really cool feature. We have observers and observers. I'm saying there's a new way of implementing observers into Zookeeper. So there's lots of stuff that the community doesn't know, and probably because the Zookeeper community was not very active during the past years. Now I hope that people will try to take a look to the new features in Zookeeper, and they try to use it, and hope that really that in BookKeeper and in Pulsar we can leverage those new features.
Yeah, that's great. Yeah. Can you tell a bit more about the upcoming features for the next BookKeeper release?
Okay, sure. I know that we are working on possibly do not write to the journal in order to reduce the write amplification. I know that this is from Splunk. I know that CloudNative is working for SNI security. I know that there is a free work about being able to support non-Java clients. This is from Jaya, from CloudNative. I expect that the new feature of Bookkeeper will contain new enhancements in the security and in the that do not write to the journal feature. Yes, that's the most. In the community, everyone is talking about do not write into the journal and have more security features. So I expect that this is the future.
Okay, great. Since we have already run out of time, thank you, Enrico, for sharing, and thank you, everybody, for joining us. We have a new session. Maybe we can just move to that session and end it here. We can have more discussion with Uncle in the Slack channel or in email and in other channels. Yeah.
Thank you very much.
And you can, yeah, and you can also connect Uncle in the chat. Yeah. I believe that you will be here available for a few more moments.
Sure.
And there are more questions coming from other platforms, and I will ask them to forward it to you, or maybe later in Slack.
Okay. Thank you. Thank you, Jennifer.
Okay. Thank you. Okay. Thank you, Enrico. Thank you, everybody.